Hello. I want to say something about energy efficiency and comfort when it comes to hot weather. And it's Madrid, where I am at the moment, and we've been having a terrific heat wave with temperatures getting up to around about 40 Celsius in the middle of the afternoon. And it's very nice to get the windows open at night and let the cool air in and early in the morning. Of course, when it gets very hot in the day, the outside temperature is hotter than the inside temperature in buildings, and so the sensible thing then is to close all the windows. You wouldn't leave the windows open on a winter day to let a lot of cold air in and make you uncomfortable. So don't leave the windows and doors and things open on a hot day and let hot air in from outside. People mistakenly think that there's some sort of cooling breeze. Well, if it's a hot breeze, don't let it in. And you find that your house will stay nice and cool if you close the windows and the curtains and the interior doors to prevent drafts, just as you would on a cold day, because you don't want hot drafts coming in to your nice cool house. But later on in the evening and early in the morning, it's nice to open the windows and to get a cool breeze into the house. And one of the things I want to talk to you about is ventilator fans and how to use them very well, and if you feel like a bit of engineering, doing some modifications to your ventilator fan to make it more efficient. So let's just do that. I'm going to show you the ventilator fan that I've got. I would like to show you the process of modifying it to get these nice helicopter-shaped blades or wing-shaped blades. You might wonder why it is when you buy ventilator fans in the shop that they have great big flat, great big sort of hand-shaped blades here in the form of sort of almost a circular shape of the blade. And it's not a very efficient shape. I don't know why they do that. I think one of the reasons might be is to make the fan motor go so slowly that the thing is fairly quiet. And you'll see a disadvantage of the modification that I've made is that this fan is perhaps a little bit noisier than when I first bought it. But let's have a look at these blades. The aim was to get blades that were much more like a helicopter blade or the wing of an aeroplane, and the designers of these things know their stuff. They're pretty good, and helicopter blades and helicopter rotor blades and airplane wings are pretty efficient and pretty good. If we look at the shape of these blades here, you can see what I've done. I've taken the aluminium, which used to extend out into this area here, and bent it over to give an aerofoil section of a wing. There's the leading edge of the thing, which has a nice curve on it. Here's the trailing edge, which is nice and sharp. And if we look at the thing from sort of on top, if I look at it from this way, there you can see the leading edge of the thing, which is curved over like that, and then there's the trailing edge of the wing, and that's a classic airplane wing shape. There it is, seen from another angle. It was fairly easy to bend these bits of aluminium and to sort of cut the edges of the thing round. You've got to be careful that the three blades still continue to be about equal in size and shape, and certainly in their mass, so that as the thing spins around you don't get a lot of wobbly vibration, and you need to plan to do that. Now the other thing about doing this is that the thing is driven by this 4-pole induction motor at the back here. And the 4-pole induction motor in Europe, at any rate, likes to run at a speed a bit less than 1,500 RPM, about 25 revolutions per second, which is half of the mains frequency, and that's got to do with the way induction motors work. All induction motors run a little bit slower than the frequency of the mains that they're connected to, and that little bit slower is called slip. But if you make the slip too big by having a very big load on the thing, the induction motor is overloaded, runs too slowly, consumes a lot of current, and isn't very efficient. Also, it gets very, very hot. You can see these sort of cooling slots in the motor itself. The fan is actually self-cooling because the airflow that's created by the fan cools the motor. But the motor is much more efficient if you let it run a bit faster. And by reducing the size of these blades, not only does the whole fan spin a lot quicker, but the load on the motor is a lot less, and that allows the motor to be a lot more efficient. So I'll turn the thing on, and you can see the sort of thing that we've got. Let's do that. It's a bit noisier than when I first got it. I've taken the cover off the blades here, so I'm not going to sort of reach out and touch them. And now I've got something where the motor spins quite a lot quicker. The blades are in efficient aerodynamic shape, and if I come over here into the kitchen, there's the fan blowing air towards the door. There's the fan itself blowing air towards me, and the air is moving out of the fan quite a lot quicker than it first came. It's probably leaving the fan in a narrower jet than we first had. Here's the fan. The air is probably leaving the fan in a narrow jet like that then spreads out because of vortices, and ends up moving a lot more air than it would have done beforehand at the low speed that it was coming out. I haven't measured the currents flowing in the motor and what the speed of the motor is, but you can look up elsewhere on the internet the information about the efficiency of electric motors, induction motors of this sort. So there we are. I'll say goodbye on that note, and if you feel like turning the fan blades of your fan, they have to be the aluminium sort really, if you're going to modify the size and shape of them. If you feel like modifying your fan blades to get something more like a helicopter rotor or a wind turbine or an aeroplane wing to make it more efficient, then you can move a lot more air for a lot less electricity. So there we are. Thank you very much for watching.